next speaker will be our own Mr. Vladislavs Bezrukovs on recent development and activities in VIRAC. So please, the floor is yours.
Thank you. In my talk, I would like to summarize some activities what we are now implementing in VIRAC related to our two antennas at T52 or T16. So I hope slides is also going.
Do we see the title slide at the moment? Yeah, no, it's the
so it's slide. Some halted. So two antennas, and many words already was taken showing about these antennas, and these antennas both equipped with broadband cardiogenic receiver 4.5 and 8.8 gigahertz, which is our probably main instrument, very sensitive, and almost all observations are done with these receivers. Additionally, we have L-band receiver developed by our own colleagues, Mats Bladers and technical group, working from 1.4 to 1.72 gigahertz. Also quite nice and allow us work in different tasks, but this is not cooled receiver, it's a warm receiver, which reduce a bit its area of implementation. Next field is solar studies, and here I have old slide representing solar spectral polarimetric receiver, but tomorrow you will see new one which installed in this year in talk by Dmitry Bezrukov in tomorrow morning session. But this is also one of interesting topic about our studies is mapping of the sun in high frequencies. We in this year and in last year implement several projects related to radioastronomical observations, and these projects which are financed and implemented by us. Here is no mentioned other projects. Additionally, here is some projects international, which is not funding, but we implemented in community like EVN or our colleagues. So main is, of course, is galactic maser project and galactic maser observations in several projects and ways, so single dish monitoring and VLBI as well. Very intensive cooperations with Torun Observatory and Irbane in maser flares, and now in light VLBI, so-called light VLBI. I try to explain it later what we mean about here. And additionally, we are looking for masers in comets. And we have interesting topic, try to find out if it's possible with single dish in L-band to catch flares or maser flares in comets. Additionally, we have variability studies of safe at radio galaxies like Persei Alpha. In Oleg Ulyanov already told, we have very nice collaboration with Ukrainian colleagues and Ukrainian telescope in Zolochev in implementing this activity. Next is application of a forward scatter radar method for the detection of space objects. This is a topic mostly like applicable for satellites and space debris. So it's in near space, but also implemented in VLBI regime. Big time-consuming project that we are not really involved, but we provide our time from our telescope. It's a CHIME fast radio burst detection with EVN dishes, and we participated by our telescopes here. And of course, solar microwave spectropolarimetric observations with our Irbane T52 telescope. And of course, EVN participation So this is our main topics and main time what we are spending in our telescopes. Speaking about finance, so these projects are funded by Latvian government mostly, and you see that they are maybe not so fancy in the European scale, but they're very important for us. So this is a topics that are supported and hopefully will be supported in future as well. One of probably bright collaboration, it's EVN, of course, and currently we work in 4 bands, 1.6, 5, 6.7, 8.4 gigahertz. And as I told, like CMX band, it's a cryogenic receiver, but even in L band, with one receiver, we succeed with some good results and provide our data to UN community. It was already mentioned, we have long major monitoring programs, which now it's, I would say, more than 4 years. It's almost 5 years, and we will continue it as well. And again, we are lucky to have our own telescopes in observatories, so we can spend our time for monitoring programs, which is quite difficult to obtain in our observatories, for example. And additionally, we just finished project in end of August called simply Galactic Magic Project, led by Ivar Schmelt. And one of the ideas or goals of this project was looking for excited OH masers, and we got several nice results. Currently prepare papers about these results. So this is also would be continued in next year. So it's monitoring and looking for new objects on the sky. Last years we tried to catch comets. Unfortunately, in L band, receiver is not so sensitive, but we try to improve it. And currently we have developed methods which allow us to follow comets and try to understand what we see. In more details, Karina Stiermante will show in her poster and tomorrow and end of the day. So hopefully in next year we will have more sensitive receiver and continue this topic. And here is additionally maybe additional collaboration with Ukraine. So we hope to get time in Zolochev telescope in 22 gigahertz to continue these studies in both the antennas, our and Zolochev antenna. And nice pictures and nice collaboration about Perseus studies. And here, it already was mentioned, was participated even 3 antennas. So we have Zolochev and 2 our antennas, and 3 of them are in same time or in several time slots looking for variability in this kind of objects. Here, additionally, it should be mentioned that we combine not only radio data, but also optical data from optical observatories. And thanks, for example, for Baldone in Latvia University, which able to provide optical data and combine them with radio data. In more details, you'll hear tomorrow from Sukharev Artem talk in the middle of the day. One of the topics that are quite interesting and promising, hopefully for us, it's light VLBI or the light EVN in this case. So we're interested to use our own SFX correlator, install it in our cluster for interferometric observations. For example, with 2 antennas, T16 and T32, including our antennas like Toru in Onsala, Italian antennas, and make small EVN-like interferometer, which could be very flexible for observations and easier to obtain observational time and time for data processing, of course. And one of a good example of such collaboration, but in this case, we are not processing data, but providing only observational data. This is a precise pinpointing, repeating chime sources with event dishes. Thanks to Franz Christen, who provided these slides, Urbane several years participate in this activity, and it already was mentioned today about fast radio bursts, which is quite intriguing objects in universe and not really understandable what physics of these very bright and very short impulses, and difficulty to find repeating bursts and find and detect them. And if we use EVN, we can pinpoint it with very good detalization. And currently, it was done with several fast radio burst sources where it was pinpointed with up to 2 millisecond precision. And here, maybe nice slide about Urbane. So Urbane not only participated in this activity, but if you look for time, so we are provided most time for this community from our antennas, so no, T32. And this activity resulted in this year with 2 Nature articles which are submitted, and probably this or next year will be published by Kenzie Nemo and Franz Kirsten, where Urbane also is in co-authors list. So it's probably a great pleasure for us. So this is like some short description what we are doing with our antennas in last months, last years, but what we are planning to do in the future. So first of all, we realize that our antenna with main receiver in the center, it's limiting our bands, so we can't use several wavelengths in same time. So currently we make RT32 upgrade and install new vertex room, which is a bit bigger and allow to place several receivers on the top. And so it's of course not be simultaneous observations, but it will be placed for receivers starting from L band up to 22 gigahertz. So it should be greatly improve our feasibility to use our antennas. But if so, with vertex rooms, we are quite sure how to do it. But the next step, if we are going to higher frequencies, we need to improve our surface because current measurements which did with laser scanners show that our RT32 surface is not so good. So it's around several centimeters precision, which is satisfactory for 8 gigahertz, but limit us in higher frequencies. So in next year, we are planning to equip our antenna with a radio holographic system, which allow us to align surface, hopefully much better precision, and open for us a higher frequency window. So next step, of course, it's a 22 gigahertz receiver, which is for probably not next year, but next year's plan. But for near future, we are looking for possibility to improve our L band with cryogenic receiver, and currently already made first designs of L band feed horn, which is huge. So if you see here, it's around 4 meters length and more than meter in the top view. But again, so this is planned for next year. So our telescope will be equipped with cryogenic L band, which also open us possibility to work with even laser lines and improve event sensitivity. So this is short plans for future. I didn't mention some tasks from European Space Agency, which are also quite interested in our antennas and in tasks with satellite communications. And we are thinking how to improve RT16 and RT32 to be able work not only as a radioastronomical instruments, but also as a ground station for satellites for some tasks. So this, I think, will be very short and like an overview what happens here in Urbana in radioastronomical directions. So thanks, and waiting for your questions.
Yeah, thank you, Vladislav. Do we have questions from audience? Maybe while people are thinking on their questions, a small discussion and a question from my side. So you already mentioned several of the upgrades and improvements we are planning and implementing right now, but could you maybe say, in your point of view, which of them or maybe some additional improvement needed in future would bring the most impact on scientific output just out of the gate? So would it be moving the L-band receiver to cryogenic, so the cooled solution, or moving forward with the higher frequency bands, improving surface accuracy, or maybe something else which was not discussed in your presentation?
Yeah, so maybe it's like a complex question, because for L-band, it looks near future, which are very promising, and me and astronomers waiting for this solution. If you are looking for 22 gigahertz receiver, which should be able to work also with satellite communication, this would be very promising for EVN, for our like incomes, which can be from satellite owners. But this may be more for the future, because we have, first of all, to improve surface, prepare our telescope for higher frequencies, find out how to make 22 gigahertz receiver. But I think it's also very interesting for community, and maybe colleagues can help as well and say what they think is better for us, or what kind of direction we have to make a priority, for example.
I have a question.
Yeah, please.
I think that in all these developments, you are not making any plan. I think probably it's not possible to use the primary focus. Or was I wrong? I didn't notice this.
This is quite impossible in this case. So we think about use primary focus as a place for receiver, but it takes quite complicated technical solutions. So we decide better to use bigger vertex room, which also be able to host these receivers. And I know we will think about brand receiver in primary focus, but I think it's quite difficult for us. So we have to find some solutions for secondary focus.
Yes, I was thinking more than this. Yes, I was also thinking, as you said, brand receiver, but I also was thinking about the solutions found for Medicina Noto, where you can move the subreflector. This is something which could be in some way borrowed from that development.
Yeah. Okay. To participate in this discussion, of course, it would be relatively easy from my point of view as the head of the engineering and technical operations to make a movable secondary mirror platform. But the space for the receivers themselves and the feeds would be very limited. And we do have quite a sophisticated solution in that case to route vacuum lines and power, etc. So in theory, maybe it is possible, but it is a very high-level upgrade needed.
Okay, thank you very much.
Here is maybe, so I agree, it's technically maybe realizable, but financially it's quite difficult for us.
Okay. Thanks both.
Okay, thank you, Vladislav, for this presentation and the discussion.